In this video, we're going to consider the relationship between demand elasticity and revenue. So before we get into the details of that, I've already told you that the critical value here is 1. Is elasticity of demand greater than or less than 1? To kind of set the stage to think about this intuitively, I want to take a demand curve, show you a few prices along that demand curve, and talk about how those different prices affect the revenue that a firm would be earning. So suppose that you're a firm and you've got a demand curve, you're facing a demand curve that looks like this, and let's say you choose to set your price, at least initially, at a very low level. Call that P1. At that price, you can draw a line to the demand curve. You'll sell quite a few units, but you won't sell them at a very high price. And we'll call that number of units you sell Q1. Now, notice that when I draw this price line and this quantity line, I have formed a rectangle along with the X and Y axes. This rectangle, the area of this rectangle, tells you the total revenue that the firm would be earning. Because total revenue, TR, is equal to the price that you're selling your product for times the quantity of units that you are selling. So that rectangle, the area of that rectangle, is equal to the height of the price times the length of quantity. So that's your total revenue. All right, now let's suppose that you chose to increase your price from P1 to P2. Can represent that by now drawing a line from P2 over to the demand curve. And notice that you are going to sell fewer units. All right. But even though you're selling fewer units, on the units that you're still selling, you get to charge a higher price than you were charging before. Okay? Now, if you're selling at a price of P2, this rectangle represents your total revenue. And you can compare this rectangle, this taller but skinnier rectangle, to this shorter but fatter rectangle by looking at a couple of different regions on this graph. So this area right here between Q1 and Q2, that represents units that you're not selling anymore. And so that is a loss of revenue. So I'm going to highlight that area in red. That's revenue that you were earning by selling those extra units that you're not earning anymore. However, on these Q2 units that you're still selling, you get to sell them at a higher price. And so this rectangle that I'm highlighting in green represents extra revenue from raising your price. And just eyeballing it, it's pretty obvious that the revenue that you give up by raising your price, in this case, is less than the revenue that you gain by raising your price. Okay? All right, so now let's move on up the demand curve. Let's raise the price again. Call the price P3. Where that price hits the demand curve, we get our new quantity, Q3. And this now represents our total revenue. And now let's say that you go from the price of P3 up to this price, which we'll call P4, the last price we'll look at. Okay. Now between prices P and 4, between these 2 points on the demand curve, once again we can look at total revenue lost and total revenue gained. The total revenue lost is the units that I'm no longer selling when I shift from Q3 to Q4. So it's going to be this area right here.
No. Hey, no, don't grab Nightly.
And I can also look at the revenue gained. That's going to be on these Q4 units that I'm still selling. It's the higher price that I get to charge on those units. And now, once again, eyeballing it, you can compare revenue gained versus revenue lost. And it looks like between those 2 points on the demand curve, it's actually the lower price that gets you more revenue, because raising your price loses you more revenue than it gains you. Okay. Now notice that this demand curve has the same slope all along, and the distance between P1 and P2 is the same as the distance between P3 and P4. And yet, even though those two things have stayed the same, the slope of the curve between those 2 points and the distance between those 2 points, in one case, the higher price gives you greater revenue, and in the other case, the lower price gives you the greater revenue. What's going on there? Well, it all comes down to elasticity of demand. Remember, the definition of elasticity of demand is the absolute value of the percentage change in quantity demanded divided by the percentage change in price. Between these 2 points on the demand curve, when I lose some output, when I'm not able to sell as many units, in percentage terms, that's not a large percentage. Q2 is still probably something like 80% or more the size of Q1. Whereas between Q3 and Q4, even though the absolute number of units lost is the same as it was between those 2 points, this is now a larger percentage loss in quantity demanded. So here I'm losing close to half of my quantity demanded moving from Q3 to Q4. Over here, I was losing maybe 20% of my quantity demanded. Okay. What about prices? Prices are increasing at a pretty fast rate between these 2 points on the demand curve. P2 is several times larger than P1, right? This is maybe, 3 times the price of P1. Whereas P4 is, maybe 25%, 30% greater than P3. So even though the absolute dollar difference between these 2 points and those 2 points is the same, the percentage dollar difference is much bigger between those 2 prices than it is between those 2 prices. So here, quantities are changing slowly, prices are changing quickly, so you care about the price. The higher price is what's going to dominate in that calculus. Between these 2 points, prices are changing slowly. It's quantities that are changing quickly. And so the quantity effect is going to dominate your revenue calculation between those 2 points. Okay? And that leads us to the following. If I know that whichever of these 2 things is changing faster, that's going to determine whether I want to charge the higher or the lower price. That tells us if this ratio is less than 1, we say that demand is inelastic. And higher prices are going to equal higher revenue. Okay? That would be because if this calculation is less than 1, quantities are changing slower than prices are. So wherever the higher price is, that is going to dominate in terms of revenue, the lower price. All right. What about if this is greater than 1? In that case, we say that demand is elastic, and lower prices are going to result in lower revenue. Sorry. Lower prices are going to result in higher revenue. Why will lower prices result in higher revenue? Because it is the quantity change that is dominating. Quantities are changing faster than prices, so you would rather sell more units at the lower price. That would generate more revenue for you. Okay? What if elasticity of demand is exactly equal to 1? Well, that would tell you that prices and quantities are changing at exactly the same rate. And if that's true, we say that demand is unitary elastic. Okay? And in that case, both prices generate the same revenue. If elasticity of demand is equal to 1 and it's unitary elastic between those 2 points, doesn't matter which point you choose, which price quantity combination, you're going to earn exactly the same revenue. Okay? Now, this brings up an important point, which is that along the same demand curve, demand can be elastic or inelastic between 2 points on exactly the same curve. So between those 2 points on the demand curve, we've got inelastic demand. The higher price generates more revenue. Prices are changing faster than quantity demanded. Between these 2 points on the same demand curve, demand is elastic. Quantities are changing faster than prices. The lower price will generate more revenue. So elasticity can refer to the demand curve as a whole. If you're comparing 2 demand curves to each other, and one of them is quite steep and the other is quite flat, you can say this demand curve is more inelastic and this demand curve is more elastic. But even on each of those curves, there are going to be between 2 given points, there's going to be an elastic region of this demand curve and an inelastic region of this demand curve. And same thing with a steeper demand curve. Okay, so elasticity can refer to the curve in general, or it can refer to regions of the demand curve, right? The difference between 2 points on a demand curve. Last thing I want to talk about in this video is extreme values of elasticity. So that would be if elasticity of demand is equal to 0 or elasticity of demand is equal to infinity. If elasticity of demand is equal to 0, that must mean that we've got a 0 in the percentage change in quantity demanded. And if elasticity of demand is infinite, that would mean that it's a percentage change in price that is 0. Okay, so let's think about the logic of those two situations. If elasticity of demand is equal to 0, and therefore the percentage change in quantity is equal to 0, that means that no matter what happens to the price, if price goes up by 1% or 20% or 100%, quantity demanded is not changing. That means you've got a demand curve that is a vertical line. Price can go up, price can go down, but the quantity demanded is going to remain the same. All right? If you have a perfectly inelastic demand curve, that's what we call this, by the way, perfectly inelastic. Then if you had an initial supply curve there, and let's say that supply reduced to S2, nothing is changing in terms of the number of units that consumers want to buy, but the price is going to change. P1 is going to be relatively low, P2 relatively high. Okay. What about elasticity of demand being infinite? Well, now it would be quantity demanded that is some positive or negative number. Percentage change in quantity demanded is some positive or negative number, but the price doesn't change. Percentage change in price is 0. Well, what is that going to look like? That means no matter what quantity of units you're at, the price remains the same. So that, instead of being a perfectly vertical curve, demand curve, it's going to be a perfectly horizontal demand curve. It's going to look like that. So now you can imagine a couple of different supply curves. Call this one S1, and then suppose there's an increase in supply to S2. The price is remaining the same no matter what, but consumers are going to change the quantity of units demanded. Q1 and Q2. All right. A quick practical question is, do these two different types of demand curves actually exist? In the case of perfectly inelastic demand, at least perfectly inelastic across all prices, the answer is no, or at least probably not. Okay, it's very difficult to think of an example where consumers would not change their behavior at all, no matter how high you cranked up the price. And the reason for that, first of all, is people don't have unlimited budgets. And also there's almost always some way that they can reduce, at least by some amount, their consumption of a product. Even if you're talking about even if you're talking about something that people really need, like insulin. If you're an insulin dependent diabetic, you have some ability to control your insulin levels with with the food that you're taking in, or at least control the amount of insulin that you need to shoot up with, based on the amount of food that you take in. And so even an insulin dependent diabetic, if the price of insulin got high enough, would have some incentives to start moderating their behavior more to consume less of it. However, perfectly elastic demand, this is more of a possibility for describing real markets. And that is, in certain markets, if you're selling exactly the same good or pretty much exactly the same good as anybody else, that's going to mean that if you raise your price at all of your customers will just go somewhere else and buy from one of your competitors. So, for example, when you're thinking about like gasoline, the demand curve for gasoline in general might be pretty steep, right? But if you think about the demand curve that a particular gas station faces, that gas station is going to face a pretty close to horizontal demand curve. Because if you're a customer, the gas that you buy doesn't really matter if you get it at Exxon or Shell or Arco or whatever. It all runs pretty much the same in your car. So the demand curve for gas might be very steep, and that would just tell you that if the price of gas at all stations goes up simultaneously, customers are going to buy pretty much the same quantity of units as if the prices go down at all stations. You're not going to get a big change in their behavior. But if you take just one gas station and you allow it to raise its price or lower its price while everybody else stays the same, well, customers are really going to change their behavior quickly. If your corner gas station raised its price by $1 a gallon and none of the other gas stations did, you would instantly just go to one of their competitors. Or if your corner gas station cut their price by 50 cents a gallon and nobody else in the city did, well, then you would immediately only buy your gasoline from that local gas store, right? Your corner store. So perfectly elastic demand, this is going to come back up when we talk about perfectly competitive markets, when pretty much all the firms are selling exactly the same thing, and it's easy to buy from competitors. There's lots of sellers offering the same product.